Ok. Mais 2 minutinhos, já começamos. Olá, boa tarde. Ok, então para esta aula, a ideia é continuar com os exercícios da aula anterior. O continuar é um bocado, vamos continuar com aspas, porque em boa verdade a ideia era começar pelo 1 e eu comecei logo mais à frente. Mas agora, veja lá se... ok, está a funcionar. Está a funcionar. Portanto, em relação a... Quem é que teve tempo de preparar as aulas em casa? Você começou pelo fim? Ah, boa. Está bem. Mais alguém? Ninguém? Você começou pelo princípio, diga-me, por favor. Fez todos, mas começou pelo princípio. Vá lá. Ok. Está bem, então, o resto da malta, não teve tempo de olhar para isto? Sim? Conseguiu? Ok. Então, eu vou dar só um bocadinho de tempo às pessoas que ainda não estiveram para tentar fazer o exercício 1 e por aí fora. Não sei se vocês já tiveram a oportunidade de olhar para o trabalho prático. Já agora, vamos resolver uma coisa acerca do trabalho prático, que é, aqui na turma 2 é onde há mais gente que ainda não está na lista oficial, por isso eu se calhar vou completar aqui a lista, que é para depois lançar uma nova versão dos grupos, já com a lista completa. Portanto, espera lá, deixa-me ver se eu faço já isto aqui à vossa frente. Posso partilhar o ecrã para vocês poderem ver. E também está ali, exato. Então, aqui, aulas. Ok. Então, quem é que não está aqui? Henrique, você diz que afinal está, não é?
Sim, aparece mais em baixo. Mais em baixo. Sei eu sou da coisa que já aparecia.
Find Henrique. Está ali, pronto.
Não, é só para aparecer.
Mas está um outro em baixo. Henrique Jorge.
Sim.
Ok, pronto. Mais malta que não está aqui. Você chama-se, diga-me outra vez, por favor. Ana, exatamente. Deixa-me procurar aqui. Find Ana. Está aqui, pronto, você já cá está. Mais alguém que não esteja cá? Podem ver também aqui nesta lista do e-learning. Eu já lá coloquei o PDF. Aqui está. Programação de sistemas robóticos. E depois já tem aqui os grupos. Portanto, neste PDF, se vocês não virem aqui o vosso nome, é grave. Toda a gente vê aqui o nome? Ok. Pronto. Então, menos uma. Isto. É tão raro a versão 1 ficar final. Normalmente tem que fazer não sei quantas versões. Então, diga. Aparece ou não? Era isso?
Não estava a encontrar isto.
Ok, já encontrou? Sim. Veja lá. Se não estiver... Não, isto é só para a malta que te escreveu mais tarde. Os que estão inscritos desde o início, em princípio. Pois você, André. Então você está aí muito calado. Ah, bem, mas se eu não puser aqui o seu nome, já não lhe dou grupo nenhum. Portanto, é André que é? Como é que se escreve? R-A? C-A? C-A-O. Sim? Deixa-me só mudar aqui o André para a letra maiúscula. Ok, qual é o seu número micrográfico? Ok. E o e-mail? andrecavaco@ua.pt. Ok, pronto. Então eu acho que só falta você aqui, deixa eu ver. No teu livro. Ok, você já cá está. E P2, você fica na P2, não é? E depois, deixa eu ver aqui se há algum grupo de 2 pessoas apenas. Há aqui um grupo de 2, que é o grupo 12. Portanto, você fica no grupo 12. 12. Não, mas espera lá. Não, mas acho que enganei, porque aqui você ficou num grupo de 4 pessoas. Não é o grupo 12, não. É este aqui. É o grupo 9. Afinal, não, pá. É o grupo 9. 9. Ok? Agora sim, o grupo 9 tem 3 pessoas também. Pronto, André, você fica no grupo 9. Você já sabe quem são os seus colegas, é o Jorge da Silva e o João Nogueiro. Pronto, se conhece, fixe. Eu depois, hoje à noite, já publico uma nova versão lá no e-learning. Okay? Mas fica já a contar. Em relação aqui a esta aula realmente é mais curta. Se vocês prepararam em casa, não há muito a dizer. Conseguem usar as classes, sem problema, melhor ainda. As pessoas que ainda não conseguiram, tentem fazer desde o início. Eu vou só dar umas dicas de o que é que são classes e como utilizá-las. E depois vocês podem usar essas dicas para tentar fazer este exercício ou então para perceber melhor aquilo que já fizeram. Okay? Deixa-me dar aqui um exemplo completamente ao lado sobre classes. Eu hoje estou muito casamenteiro, por isso vai ser um exemplo sobre casamentos. Exercício, ou teste de classes, vou chamar. Ok, então imaginem que eu tenho aqui um problema que é o seguinte: eu quero representar pessoas e cada pessoa há de ter várias propriedades. Portanto, quando eu, por exemplo, quero representar uma pessoa com um nome, eu posso escrever assim: nome igual a Miguel. Isto é a primeira pessoa. E depois há de haver, eu vou escrever tudo em inglês, também eu estou mais habituado a escrever em inglês. Name, Miguel. Depois há de haver uma segunda propriedade que é o age. Depois, outra propriedade qualquer. Como estamos a falar de casamentos, vamos falar do estado civil. Civil state. Ok? E aqui há de ser, por exemplo, single ou married, neste caso. Então, isto são 3 variáveis que eu estou a usar para descrever cada pessoa. Se eu agora quiser descrever mais 2 ou 3 pessoas, eu vou ter que criar mais variáveis deste género. Por exemplo, vou ter que criar o name 1, o age 1 e o civil state 1 e depois então mudar para outras pessoas deste género, ok? Vamos ver aqui outro. Qual é o problema disto? É aquilo que eu já vos falei na aula prática, que é, eu com isto vou ter dificuldades em fazer o código crescer. Porquê? Porque para cada nova pessoa que eu preciso de representar, eu vou ter 3 variáveis. Aqui o exemplo são só vezes 3, mas podia ser vezes 55 ou vezes centenas. Portanto, a ideia é ter isto encapsulado. O que é encapsulado? É agrupar isto tudo num só objeto. E esse objeto vai ser uma classe. Qual é a grande vantagem da classe em relação aos dicionários? Sim, porque nós podíamos fazer isto à Python, seria, por exemplo, dizer assim, pessoas, persons, igual a uma lista, porque tenho várias pessoas, cada uma delas um dicionário, cada dicionário com uma chave nome, Miguel, depois uma chave age com o valor 25, depois uma chave civil state com o valor married. Ok? E isto seria o primeiro elemento da lista. Porquê é que eu digo lista? Por causa dos parênteses retos. Porquê é que é um dicionário? Porque está com as chavetas. Então, cada grupo de chavetas será um elemento da lista. Cada elemento da lista descreve uma pessoa. Por exemplo, mas para onde?
No final do dia.
No final. Diga-me a linha, para mim é mais fácil. Falta mais, exatamente, obrigado. Já está, ele agora já não se está a queixar. Portanto, eu aqui podia definir agora o João e por aí fora. Oops. Just leave it like that, no problem. E aqui ainda faltava mais um, não era? Malta, vou mudar para inglês mais uma vez. So now I define the third person, which would be Maria, for example. Okay, something like this. So this is a second alternative of how to represent the information, which would be much better than the first. What is the problem of this kind of representation? I use it a lot, so I don't think there is a problem with this, but there is one limitation which classes do not have, which is the fact that you are grouping all the information, meaning all the variables in a single place, in a single dictionary, or in this case, a list of dictionaries. But if you want to have some kind of a function, for example, to congratulate someone on her birthday, you could have a function like this there. You can have this function like this, congratulate, and you would have to receive here the person that you want to congratulate. So let's say this will be the person, which the function knows is defined as a dictionary. So if you want to congratulate person, blah, 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 you say print, person would be one dictionary, which would be one of the elements of the list. So you know that you could access for the dictionary person, the key name. And you can just say congratulations, and you add the person's name. And you can even put some exclamation points afterwards. What's missing here? Why is it complaining? I'm missing something. Ah, yes. No, not really. Yeah, this. So it's a dictionary, so I have to use square brackets here. To access the keys of the dictionaries, I have to use square brackets like this. Okay? In this case, I'm converting the person, the value person name, so the key name in dictionary person, I'm converting it to string. I wouldn't have to, because I already know it is going to be a string, so I don't need to convert it. Moreover, you would have to, so if the person is to be congratulated, the person would have an additional year. So let's say that the person year or age will now be the person age plus 1, growing 1 year older. Okay, because this dictionary is updated, we have to return it somehow. So we would have to do something like this, return person. So now, for example, let me do the example of the dictionaries. I define my persons dictionary, which I can print, persons, and then I will say that my new person, so let's say person, well, let's say persons 0, which I know is the first element of the list, so it's Miguel, will be used to congratulate. Okay, sorry, not like this, like this. So person 0, the first element of the list, is going to be given as input to the dictionary, to the function congratulate, and it will return a new person, so an altered dictionary, which I will use to copy into exactly the same position. Okay, so if I do this and I print the persons again, look at what happens. Copy path, CD down there, clear, and main. Okay, so the first one is a list of dictionaries, 3 persons described there. Then there is a print saying congratulations, Miguel. And finally, the new list of dictionaries printed afterwards already has Miguel with age 26. Okay, so this works as well. What's the problem with this approach? As I said before, I don't see a very serious problem, but there is a disadvantage, which is this congratulate function is not included in the data structure. So you have on the one side a data structure which will contain your variables. That's the person's list of dictionaries. On the other, you have a function which will operate this data structure. So these two things are not put together. They are separate. They are secluded. So there is a better way, which is to put them together using classes. I will show you how. So first I will put this down here. So you will know how you can use the, well, I will show you. I will change this main for main with dicts. So this is the main with dictionaries, and now let's use the main with classes. Right? Okay, so now what can we do to create a class? So to create a class, we have to start by defining the class. What is a class in the first place? A class is a data structure which will contain variables and functions all inside the class, encapsulated in this class. And you can think of it as a type. For example, when I say something like this, A is 7, what I'm actually doing is I'm saying A equals int 7. Okay, so the one on top is just a shortcut. Python, actually, Python would say float probably. I'm not sure, but in any way, either with int or float, the example is the same. Suppose it's an int. So what I'm really doing is I'm saying A is going to be a variable with name A, of course, and this variable is going to be of type integer with the value 7. Okay, that's what we are actually doing here. If we want another integer, another number, we can say B equals int 3. So now we are defining two different objects of the class integer. In terms of classes, what we do is we call A and B instances of class integer. Integer, you can think of it as a class, a very simple one, not defined by us, but a class nonetheless. So int is a class, a data type, and we can have several variables of that particular data type. Okay. In the case of the persons that we want to represent, it's going to be the same. We are going to define a person class. Okay. And this person class, right now it's not going to do anything, but I can also say person 1 is going to be a person, an instance or an object of type person. And then we can also have for more persons. Okay. So like this. Okay. So just for you to understand what having a class means, it's a data type, okay, which we can instantiate as many times as we need. So now we move on to try to do our class. A class is always going to have something called a constructor. As I told you, classes have properties and methods. A constructor is a method which must always be there and is written like this. So underscore underscore init underscore underscore is the convention name for this method. And it is a constructor. Why? Because it's always called automatically whenever you construct a new object. So you can think of line 18 as constructing a new instance of a person by calling the initialization of class person. So this line here will automatically run every code that is inside function init. Okay. So this is the constructor. Let me write here. Constructor. Now the constructor will run, and when it runs, we will need to store the information that we need for a person. So we will need to, for example, define a person's name. This information will be stored inside the property of the class. A property of the class is just a variable which is contained inside the instance of the class. So if I do cell, which is a reference to the class itself, name, I'm creating a new variable called name, which is internal from the class, which will have the name Miguel. Okay. Now, what can I do after I create two persons? I can actually, for example, print the name of these persons, p1.name and p2.name. Okay. Well, main underscore with classes. Okay, so 2 times Miguel. So we are already storing information when we run the init, which then we can access. So I create in P1 a variable called name on line 21, and then on line 24, I use the variable that I created to print. So this is working. Although both of them say Miguel, which doesn't make sense, of course, I need to be able to change the name as I please. Therefore, what we really want is to say the name here. Right? So that would be an argument of the constructor. So we just put a new argument in the constructor name. By the way, we are also going to do the same for the age. And let's say for the civil state as well. So now we have 3 new variables, but be careful. These variables that I'm underlining now are internal variables, not of the class, but of the function init. So these variables will exist whenever the init function is called, and then when the init function completes, they will disappear. So I need to make sure that I copy those 2 properties of my class. So these are variables, and these are other variables. That's why I'm copying. Make sure that I store in class properties the input arguments. Makes sense? You are not saying anything, so. All right, so far so good. So now we have this. Now what will happen? Now I must specify the name, the age, and the civil state. So let's say this is João. The age is 33, and then the civil state will be, let's say, single. Okay. Now we have, well, let me copy paste, it's easier. Now for the second person, we will have Maria with age 34, with civil state, let's say João is married, Maria is single, okay? Now, if we now print again, you will see that the names are already João and Maria. Makes sense so far. Now, if we want to access the other properties, we can also make this print a bit more complicated. We can say, I am P1 name plus aged, and I am plus str P1.age years old. Make sense? I will do the same for P2. Okay, so if I run this, I am João and I'm 33 years old. I am Maria and 34 years old. So we already have something nice, which is the ability to store all the variables in a single place, in the class instance for each person. Now, one thing that would be also interesting is to put this printing functionality inside the class, okay? So we will create a new special function, which is already named by convention, so you cannot arbitrarily choose a different name for this method. This method is used whenever you want to print the class. For example, before I write the method, let me show you what happens if I print P1. So if I print P1, what will happen is that it says the following. Oh, in the function main, there is a person object with memory address, blah, blah, blah. So it's trying to print a class, but it doesn't know how. So it just says this is an instance of the class person. That's what it says, an object of person. But we can, if we define this special method, specify how we want a class instance, an instance of this particular class to be printed. And this is how you do it. You define a text, which will be something like whatever you want to print for this class. I am, well, I can actually copy this. I am, now it's not p1.name because p1 doesn't exist, but it's the variable, the property of the class, so it's self.name. And I am self.age. Okay, so this is a text that must be returned, but let's also say whether or not this person is married. So we can add more to the text, text plus equal. I am married, let's say. I am civil state. Civil state, right. Okay. So this function, by definition, must return a string. Right now, I'm only creating a variable, which is a string. I need to return it. Now, yes, it will work. So let's see what happens when I print P1. Now it says, I am João and I am 33 years old. I am married. Okay. So we've made progress. We have a class which contains two methods and already some information inside. So now we can just remove these persons, example, with the dictionaries, of course. And now let's try to do something else. Let's try to congratulate like we did before. So what can we do to congratulate? Well, we could create a function outside the class, but that wouldn't make sense because what I want to congratulate is a person, right? So if I want to congratulate a person, then it makes sense that my congratulate function is actually a method of the class. Okay. So I'm just going to say congratulate, that's the name of my method. And now, well, to congratulate is just to say congratulations. Congratulations and the name, self.name. Right? And because I'm congratulating, I know that the person will be 1 year older, so I'm going to do self.age plus equal 1. Okay? So now look, I can say, I can print the person 1, then I can congratulate person 1, and finally I will print person 1 again. What we will see is I am João and I am 33 years old. And then congratulations, João. And finally, I am João and I am 34 years old. So you see that it worked. It's I was able to increase the age of João. Okay. So now we have a method inside the class, which is custom. Now it's not a convention method. It's custom it's our own method to congratulate. Well, now we can do whatever we want. We can also do methods that will do more complicated stuff. Let's do a method to marry two people. So if I want to marry the person that is being represented in this class with another, I have to receive the other. Let's call the other the partner, right? And what is to marry? Well, to marry is to say this, the following. Self.spouse. So spouse is a new variable which will have the name of the partner. Partner.name. Let's assume partner is also of type person. Now, I also must say that my civil state changed to married, right? Now, from the partner's point of view, his information should also change. So I can also change his information here. I can say that my partner.spouse will be myself. And I can say that my partner dot civil state will be married now. Makes sense for everyone? Okay. So let's try to get João and Maria married. So let's marry. From Maria, we call, so from P2, which is Maria, we call the Mary with João, with P1. And then we print P1 and P2 as well, both before and after. So this is going to be print before, and here we are going to have the afterwards. After. I can even, yeah, this is better to view. These are just line changes, okay? So let's see, before, I am João, 33, and I am married, and I am Maria, 34, and I am single. Congratulations, João. Ah, by the way, marrying should also have something like self.name and partner.name are married. Okay, so let's try again. Now, again, I am João and blah, 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 and Maria and blah, blah, blah. Congratulations, João, because he's 1 year older. Maria and João are married. Okay. Then afterwards, you can see that João is 34 because he was congratulated, and Maria is still 34, but now is married, okay? So this worked, no problem. What can we do in these kind of functions? These methods are nice because they can do not only the operation they're supposed to do, but also some verifications. For example, there is a strange thing now here, which is João was already married before marrying with Maria. So we can do this test. We can say something like this. If self.married, self.civil state, different, if not equals single, print, I am not sure this is a good idea. Okay, so you are trying to marry, but you are already married. So let's return without doing anything else. This is to verify if the person self is married. Now we can also verify if the partner is married. If not, self.civil state equals, not self, sorry, partner, which is the other one. Equals single. We can say are you sure you trust, and his name or her name, self, the partner dot name. Okay, and also we return because we are not sure that it should be done if one of them is married. So you can see here that now we see a print saying, are you sure you trust João because he's already married? So the marriage did not go forward and Maria is still single, which makes sense. Now this would work if, for example, João was not married in the first place. Let's say here divorced. Okay. Well, it must be single. I have, so perhaps I can do this not by the negative, but by the positive. So if not civil state single, yeah, if it's married, if he's married, then I say that he cannot. It's better like this, I think. Yeah. Again, we try. Okay, now yes, one was divorced, the other single. They are both married now. Okay. Any questions? No questions? Do you have experience with classes before? Who had experience with classes before? Can you please raise your hand? Uma pessoa só? Duas? Okay. So now let's get into some more complicated stuff, which is class inheritance. Now, what is inheritance? Inheritance is the ability to, well, okay, backtrack. I'm going to start from somewhere else, which is better to explain. And the place where I'm going to start is by saying that I need to define also something that describes a dog. So I need to declare a new class, which will be a dog. Now, a dog, like people, also has a name. Let's say this is a pet. It will also have some age, but not surely a civil state. So the class dog will also have a constructor, which will only, which will only define the name and the age as internal properties. Okay, makes sense? Then a dog will not be able to marry, but we may congratulate the dog on his birthday. So let's say that the dog would also be able to be congratulated and age. Okay, so we also have the function congratulate. Finally, we also need to print stuff for the dog. So if we need to print stuff, we would also need this str function here. Okay, and let's say that the str function is something like, well, I am a dog named blah, blah, blah. Okay, so now we have two classes, the dog and the person. And we can here declare a new dog. Let's say here that we have a dog C1, not C, D1 for dog. This dog will have name Lassie. Any of you know who Lassie is? No. You do? You're the only one. Nobody else knows. I don't know why. Well, I know why. Okay, let's say the dog is 2 years old. So D1, I can also print the dog. I will do it at the end. So I will print D1 at the end. And you can see, oops. Yeah, so now, first problem, the dog has no civil state on line 14. When I'm printing for the dog, this str, I'm trying to print the civil state of the dog. So let's just remove this part. The dog doesn't have a civil state. Okay, so now you can see that also for the dog, this is working, right? Now, what I did now when I defined the dog, did it cause any kind of concern or allergy to you, or is this fine? Didn't you get annoyed with something that I did? What was it? I'm talking about the programming side of things. Why were you annoyed, Henrique? Tell me. Yeah, okay, so you're not annoyed. You are not annoyed, you are confused. Any other person with what did I do that didn't really make a lot of sense? What I did was I copied a lot. Yeah, so like André is saying, so I was copying a lot of stuff from person to the class dog. I'm replicating code. And it didn't make a lot of sense to have all this duplicated code in the Yeah, but that would start making things complicated. What you want to have is a single class, which will be slightly different based on whether it's a dog or a person. Because, for example, let's try to do your class. I'm going to call this one person dog, okay? So let's do the class person dog. This class person dog will have a civil state? No. If it's a dog, it doesn't have a civil state, right? So first I will have to add here a new something called type. And now let's first store the type, self.type equals, well, type is a reserved name, not a good idea. Species, good. So self.species equals species, right? Now, if self.species equals person, then there will be a civil state, otherwise no, right? Now where else? Mary, well, if self.species equals is not a person, return, I'm not going to marry dogs. Oh, don't worry, also you should say or not partner. Also, you don't want to get married to a dog, so that would also be a nice thing to test. Otherwise, you can hear some barking at night. That would be problematic. Person, something like that, okay? Okay, now what? When you are printing here, also you have to put an if here. Okay? Do you get the feeling of what's happening here, Enrique? You are complicating a lot. If, and this is just a simple example. So you went down the worst path possible, which is you complicated stuff. So this person dog is clearly not the way to go, but it's one where many inexperienced people think of. So it's not a problem. It's usual that you think of that. The idea of how to solve this more elegantly is to use what we call inheritance. What is inheritance? Inheritance is what, like the name says, you inherit something from your parents. So whatever was theirs, it becomes yours. In this case, we have a class which will be called a superclass, as if we are talking about the parents. And this superclass is just a regular class which will also contain properties and methods. And what will happen is that when a class inherits from the superclass or inherits the superclass, it will take all the properties and methods of that superclass, okay? So I'm going to define here a superclass, which is just a regular class called animal, okay? Now, of course, the animal is a class, so it will need a constructor. And if the animal is a class, an animal, it will have a name and an age. Let's be very polite and have names for all animals, okay? So we would need to have to do something like this. Okay, so the animals also need to have names and ages. Then we will have to congratulate also the animal. Okay. Now, if you look at this, what you now need is to make sure that, for example, the dog will inherit from the class animal the properties name and age and the method congratulate. How do you do that? You say here animal, that way dog is inheriting from animal. And now you don't have to define, again, the congratulate method, because the congratulate method defined in line 8 from the animal will be available for the dog. The same for the properties name and age. They are defined in lines 5 and 6 for the animal, so they exist for the dog. You don't have to define them in lines 15 and 16. Okay? You just have to make sure. Yeah, how do you define the name and the age? Right. So you do it by like this. Because you know that the animal is a superclass of dog, when you receive the name and the age in these variables as input arguments, you have to convey those to the constructor of the superclass. So you say, the superclass will have a constructor for sure, which I will call with name, and age. Okay. So whenever I declare a dog, I will enter this initialization, which will then call the constructor of the superclass, which will go here and put the variable name into the property name and the variable age into the property age. Okay. So this simplifies a lot of code because I can remove all this stuff from the dog and also from the person. So now I take this away. And now I take congratulate away. You see, this is much simpler now. Oh, sorry. I forgot to say that a person is also an animal. Okay. Let's. Yes, right. You need to call the constructor of the superclass, right? Like this. Let's try again. So we tried again and it worked. Exactly the same. That means that I just changed the way I organize the information and it's still working. So this is much better organized and still working, okay? And that's what we have. This is what inheritance is all about, is to pick up properties and methods of classes upper in the hierarchy. Of course, you can have other stuff. For example, suppose that your dog, just to say that these methods that you inherit, you can override them. You can say, oh, what I'm doing when I'm congratulating an animal is very general and I want to be specific, congratulating a dog. Okay, no problem. So you redefine the method congratulate whenever you want to congratulate a dog by saying this in dog language. Okay, so now I'm doing this in dog language. Wait, for testing. Wait, Enrique, very important. I need to congratulate the dog here. D1, otherwise we don't see the Aula. Okay, there it is. You see? What was your question?
Defs are functions, right?
Defs are, you use def to define functions, yes.
A function for class that, and that function already exists in the superclass. If you override the superclass,
that's exactly what's happening here. Congratulate in 21 is overriding congratulate in 8, just for the case of the dog. Look, for the person I'm using the standard congratulate because I didn't redefine it. So for the person, it's congratulating congratulations one. Okay. What else? I can also use some different way of combining classes, which is called composition instead of inheritance. Composition is when you don't want to get the properties and the methods, but you just want to have one class inside the other. For example, I can say that my person has dogs. Let's say that each person will have a dog, which will be a dog called Bobby with age. Let's say the dog is starting newborn. Okay. And this example here is not inheritance. This is composition. Okay. Sometimes you need inheritance, sometimes you need composition. It depends on the case at hand, but these are the two ways to combine classes. Okay, I'm not sure what else can I say? I can say something else, just, well, any question about this? No? No questions? No? Okay, next, let me try to tell you about how to call functions. So init is a function like any other. So I can have, for example, here a function in Python. Let's say that I have a function which is going to be def do nothing. Okay, so my do nothing function will receive 3 arguments, A1, A2, and A3, 3 arguments. And it will do nothing, yes, and only print the value of A1, the value of A2, and A3. Okay, that's a simple function. And what I want to talk to you about is how we can go about calling this function. So there are many, many alternatives to calling a function. In particular, in what concerns the how you set the arguments. So the first way to call do nothing is by using the order of the arguments. So if you know that the arguments are ordered A1, A2, A3, you can say, oh, A1 is going to be 1, A2 is going to be 2, A3 is going to be 3. That's just using the order. And if you call this, you will see that it works. A1, A2, A3 is working perfect, right? Let me just put here a new print just to change the line. Right. Well, you can do it like we did before. For example, here, when we are calling the dog constructor, the underscore init underscore of the dog, we are using name equals blah blah blah, age equals blah blah blah. So this is using the order of the arguments. I think they are called positional arguments. And then you can use the name. So you can call do nothing by defining that A1 is 1, A2 is 2, and A3 is 3. This is using the names of the arguments. I think this is called keyword argument. Right? Then what's the advantage of using the keyword argument? Well, for me, I immediately know that 1 is going to be passed to A1. So I don't have to remember that A1 is in the beginning, A2 is in the end, A2 is in the middle. So less memory footprint, better for me, more I can focus my attention somewhere else. So I prefer this way. Also, another advantage is that you can swap the order if it suits you. For example, you can do it like this. Because now I'm naming, I can swap the order, and all of these will return the same. Okay. So with keyword arguments, you can swap the order, no problem. What else? Then you can do hybrids. So you can do nothing by specifying first the first positional argument and then specifying the others. This is a hybrid version. Some of the arguments are given positionally, some others by name. Also works. Well, what you cannot do, so it seems like you can do almost anything, but you cannot do this. So if you want to use a hybrid, you cannot put the positional argument in the end. So if you want to use a hybrid, some positional and some named, you have to make sure that all your positional arguments are at the beginning. Because if you want to put yourself in the place of the Python interpreter, if I'm going to use the position, I need to make sure that I can start counting from 0. If you give me named arguments before, I don't know how to count or where to start counting. So hybrid versions need the positional arguments first. What else? Default values. So whenever you want to have a function which will contain a default value for some kind of variable. So let's say, for example, that A3, if you say nothing, is going to be 3. If you put there this equals the value whenever you define the function, this function will also work. Well, let me not say 3, otherwise you would not see the difference. Let's say 33. So you can see that when I print this, there is nowhere A3 is 33. That's because I always define the value of A3 in any of these alternatives, in all of these alternatives. However, I can go like this, A1, do nothing, 1, 2. Now I'm defining positionally only A1 and A2, and A3, which must exist, is defined using its default value. So now A3 is 33, okay? The only thing that you cannot do is to have a default one with the default before one which is mandatory. So this will say non-default argument follows default argument. So if you want to do that, you have to put A2 on the right-hand side. But okay, you have a lot of options of how to work here. This is just a crash course on how to call functions with keyword arguments also. No questions? Okay, I will shut up and leave you to do your work. So I give you 5 or 10 minutes, and then I will ask someone to show me this usage of classes. So for those who haven't done it, try to see how you could do this example of the classes for the complex numbers based on what I explained here for the persons, the marriages, and the dogs. Okay? Okay, I give you 10 minutes to breathe, and then we speak again. If you have questions, let me know. Any questions? Because I'm still writing. After I finish writing, you can ask me, and I will push it to the top. So I can push it to the top. So this is a GitHub repository. What happens is that whatever is let me draw some. So do you have experience with GitHub or not? No? So let me try to explain the logic behind it. Because that way yeah, that's what okay. So those are based synchronized here. And you have some files here. So there's a folder and then another folder, blah, blah, blah. And if you use Dropbox will put a copy of these files also in the cloud, okay, in your Dropbox. And it will synchronize it bidirectionally. So it will copy files and have new files, it will go there. And if you put new files there, it will come here. The question is that for Dropbox, drive, OneDrive, blah, 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 this is not automatic. It's actually automatic. It's for synchronizing not really important files. Now, suppose that you are doing a very special code, and you do some kind of language. What will happen is that all vectors will stop. So for coding, you cannot have this done automatically. So what GitHub does is to not do this automatically and do the following. It will also contain, let's call here, this is going to be a cloud on GitHub. So first, it will create packages of stuff which are called repositories. Repository. So this is a repository, for example, my PSR, blah, blah, blah. Where is it? This one, PSR 2223, is a repository, right? Okay. So, and this repository was created by me, specifically. So this is my computer, mine. And I have here my code. So let's say that this is PSR 2223. So whenever so I start writing my code here. This here is where I write the code. This is my local copy. What I see in the browser is what is on the server, right? So this is my local copy, and I start explaining you stuff. When I show you this code, I'm moving here. When I'm finished, whatever is here is different. This is not the same as whatever is there, because I changed something here. That means that this synchronization is not automatic. So this is not automatic. I have to do it myself. Especially because programming, you want to make sure that the programmer says, okay, this is good to be sent to the server. So this is done in the push. Well, actually, with two steps, commit and push. So these two steps, first commit, then push, will prepare the differences in this code with respect to the server side, the original version, and put them into a package. That's what commit does. Push will send that package over the internet to the repository. And whenever you are in your computer, okay, whenever you are in your computer, you also have a place here called PSR 2223. This is your local copy of PSR. Now, why do you have this? Because you did something at the beginning that was done only one time. It was a clone. So you cloned the repository. That is just like picking up this version and copying it. But now, let's say you did this in the morning, you have a copy of what was there in the morning. So now I have to send it, and after sending it, you have to download it again. How do you do that? In your case, clone it done only the first time. Sorry, first time. After this, you have to pull. Pull is updating. Clone is copying from the first time. So I'm going to do this. I'm going to commit and push on my. So I'm going to Visual Code. I'm not sharing, am I? Yeah, okay, I'm sharing now. Okay, now I'm going to this source separator. This is the extension for the managing the source control. It says here, oh, you have a repository called PSR 2223. That's the one there. And it has several changes with respect to the original version. In particular, it has these new files made with classes, made with dicts, and some others. Okay, these others were from the other class. So I'm just going to say, add all these to the repository. Now this is not in the changes, it's in the stage changes. So I must create a package to be sent, which is created by adding a message. So this is examples with classes. Okay, this is a commit message which must always exist. Now I do commit, and now this part is done. To push is to press the blue button again and do the sync changes. Okay, once I do this, I'm sending my new version of the software from here to the repository. So now, once this is finished, I can go into the browser and refresh, go to part 03, P2 test classes. So now we have here the new files, right? But we're not done because now this is only there. In your side, you have to do the pull. How do you do this? Again, you go to the source control in your Visual Code. And then in the repository PSR, you have to go here and do pull. Try it and see if you can find the new code.
Wait, what you want to see there, you want to the browser, you want to the browser, yes. You want to see that it exists on the repository. So you are still seeing the cloud. You have to do the pull and then look in your visual code. So look at my example. After I pull, I go to the files in my visual code, and inside part 03, there is a P2, and then there is a main with classes, the file that I developed before. So you can see if you have it. Check. Yes, you have to repeat inside yes, yes.
Okay, who is brave enough to try to show me the classes? So that's exercise 4. Desculpa? Okay, so share your code. I don't know. You start. But you will share your screen, right? Okay.
P2, right?
Sorry?
Is this class P2, right?
P2, yeah. Okay, now we have your screen.
So I didn't do anything very developed.
Don't start putting the expectations, don't lower expectations.
So I just I'm trying to read what she wrote here,
Mhm.
and then the complex from the mornings. But I really don't know if this is what we're supposed to do. I was just trying things out, but I thought that this should create something like this, and it doesn't. So,
Well, so this is your solution, right? Okay, wait, let me, because you changed file, I don't know which is which. So this is your solution. Let me take a look, okay? Let me just enter with my lab. I forgot to enter with the tablet. Just a moment. This is my favorite part of the class, which is where I can beat the students because of their code. Okay, I'm here, and well, first, you don't use this, do you, Eric?
What?
This. You don't let me draw in your screen?
No, I will choose anything you want.
No. In your case, I don't know why I cannot. Could be, I don't know. So I cannot draw well.
Actually,
Don't worry. Let's try. I'm just saying that first, I will try to draw in another way. No, you don't let me draw. Here. No. Okay, so do you see the bottom rectangle there? I don't know why you have it on. It's just taking away space from your code. That's the first part. Second one, let's start with the constructor on line 5. So you have your class constructor, no problem. And then you just copy to the properties R and I. That makes sense. In the add, you just said.
I don't understand the why part.
Because if you want to add, when you are adding one complex number with another, right? So this add will be a function inside one of the complex numbers, which must have information about the other in order to add. Make sense?
Yeah.
So what do you think should change there in order to?
I don't have anything related to why the whole thing.
Anyone can help, Henrique? Any idea? Basicamente estamos a discutir aqui o.
You have the entity which is which is from what I understand, you are trying to call the function add online 35.
Yes.
And C1 will be self, and then Y will be what's inside the parentheses.
What's in C2 exactly?
So if you want to have the numbers, you have to put the ND self, which is self. And then C and D will be Y. I'm not sure if you have to add anything.
Well, A and B would be the way to extract the A and B parameters from a tuple, but now we are not representing a number, a complex number like a tuple. Now we're doing differently. Diga.
Self points R and Y and
Why?
And Y points R and Y points.
Exactly, I think so. So can you help him? What should he write? That's it. So for example, in line 10, A is supposed to be the real part of the first number. So how do you get the real part of the first number? Yeah, that's the real part of the first number. So put A equals that. No, the other way around. A equals self dot R. That's, and then B would be the imaginary part of the first number. Like Anna said. Yeah, exactly. Now for C and D, how do you do it?
Yeah. Y.
Exactly. Okay, you can thank Anna.
Yeah, so now, is this right now?
Yeah, now it works like this. Of course that, well, if I would do this, not just yet, because, so first comment is about, it made sense in the theoretical class to have defined A, B, C, D. Now you're just using A, B, C, D as intermediate variables to then use A and to then using 16. That's what the example, I call this, the example of A equals 7, B equals A, C equals B. Now, why do you have the B? You could just say A equals 7 and C equals A, or you could just say C equals 7. So in this case, I don't think that you need to define A and B. Can you take them away? A, B, C, and D. What? Can you take them away? Oh, don't delete. First, use that in order to replace what's in the bottom.
Then where do I do things? Here?
Yeah, yeah. So, but you are not using the proper, well, okay. What do you put there? Exactly. Exactly. Now you don't need the from line 10, 11 to 15.
Yes.
Yeah. That's the first problem. Now, the second problem is when you compute, so the addition of two numbers is going to be a new complex number, right? Now you have two options. Either A, your new number, which is the result of the sum, will be a new complex number. If that's the case, then you need to instantiate a new object of class complex, which you are not doing on line 14. You are creating a new tuple. Doesn't make sense that we are using this. Okay. You have to return a new instance of the object if you want. So how do you create an object? Like, take a look at line 28.
Or complex.
Real, imaginary.
Like this.
Like this, exactly. Now it should work. Now, if you do this, what will happen is that when you add, you are adding one number with a second number and returning a third number, right? Makes sense, Eric? Therefore, in line 33, your third number, the result is being ignored. So you would have to say something like C3 equals C1 add C2. C3, yeah, and now we print C3. Okay.
This, right?
That's another. That's something else. Okay.
Yeah.
But with this, that's what will happen. Actually, now you can define the string. Otherwise, we cannot test anything else. Can you try to define the str? Not print. Str only needs to return a string. Doesn't need to print. Just.
Oh, I just write the string.
You just write return, and then you start writing your string.
So C1 plus C2.
You want to print your number. So let's say that you want to print. Just say like this: 3 plus 7 5. STR yourself dot real. That's the 3. Plus you have to add the character plus. Plus you have to put your STR converted to string of the cell. I, that's the 7, the imaginary part, plus character I. Make sense? Yes.
I want to search on the internet and one of the solutions doesn't present the screen part, they only like functional or it does.
Yeah, that's the alternative B. Just 1 minute and we go there. That's alternative B, which I think makes more sense, but now we're going all the way with this. Is it done already, Enrique? I didn't see. Return str self. Okay, makes sense. Now you print, when you print it. So first you can comment the multiplication part. We don't need it. Lines 36 to 39. In my case, yes.
So like this?
Perhaps you can print also C2, no? Because we are adding C1 with C2 and then the result is C3. So you can perhaps print C2 as well. Okay, let's try it, see.
This doesn't general. Yeah.
Doesn't print anything?
Yeah.
Okay, can you go down in your file? You have nothing else? Yeah, like I said in the first class, okay, good. That's it.
I copied the children line, but then we want to copy the. Yeah. Okay.
Okay, so now 5 plus minus 2 is 3, so it makes sense. I think it's working. Okay. Now, the question from Anna was pertinent. It was the following. I gave you option A, which was you have one number, you add a second number, and then you receive a third number, right? But you could have option B, which would be you have one number, you add the second number, and then the first number will be incremented. So the first number will change. Do you know how you could do that? Anna, you can try to help since you asked the question. What would you need to change in order to do this option B? Yeah, no, yes, so your question was, do we really need to return a third complex number? Why can't we change the values, the real and imaginary components of the first number, right? So how would you do that? Do you have an idea? I think, Eric, you started doing something while I was talking to Anna. What did you do?
Because you said we don't need another.
Huh?
I will, it's not R really, it's R plus 5.
Exactly, that's it. So you're just changing the real part of the number, right? Now you don't need to return. Why? Because you are adding one number with a second number and there is no third number to return. The result is the new values of the first number. Yes, exactly. Now when you are printing, it says none because there is C3. When you say yeah, there is no C3 is nothing. C3 doesn't exist. There is no third number. Yeah, you still add, but you don't take the result because the result doesn't exist. Okay, makes sense? Anna, makes sense? Okay, makes sense. Now I will try to do a trap, but I still have time for the trap. Can you try to do the multiplication?
Sure. So then I will use this, just itself dot não sei quê.
Self dot não sei quê. I don't know what it is. No, it's that. It's not slow. It's the normal speed. Don't worry. That's how you program. You don't program. Do I look like I'm very fast programming? Typically, I do. No, that do you know why? Because I'm much slower than you. Because I program. Well, you say, you did this in 1 minute. No, I did this in 1 minute plus 15 years. That's the experience I have. So this is. It's normal that this is slow. That's how it is in the when you start. Okay. Please help Enrique, everybody.
Now I should also, can I do the same in the multiply as I did in the dash, or do I still need to return?
It's to use Anna's idea of having the first number being altered, not returning a third number.
It's something that I did in the first time. So
Yeah, you fell into the trap. You fell into the trap, Enrique. So that is where you really need temporary variables. So you can create, for example, dr. And yeah, okay, you can, sure. Yeah. Exactly. So you understood. You all understood why it needs to be done like this, no? It must be. Yeah, I will tell you. So. So I have number A, which is 3 plus 7i, and I have number B, which is 4 plus 8i. Now my multiplication is, can you tell me the formula? The formula. Okay.
It's a.
So the real part is what?
Yeah, really is A dot R. The real part of the number
A.
So like 3. You want the formula, right?
Se for usar a real part, esta de number 1, so N1, N2, A. Sorry. A, G, C, D. Yeah, okay, give me the formula now.
Now it's A times C.
A minus.
No, times C.
C.
Sorry. Minus so B D.
Okay, and the imaginary?
It's A D minus.
I think it's plus, right?
Well, I have minus then.
H minus.
But I can double check. And C B because it's not.
Okay, so what was happening is that you were doing like this.
you are going to first compute the real value. You are going to say it like this. Real. Equals infinity minus u. But because we are already instead of self dot r. So self dot r is already a. So when you are going to compute the image, so because of that, the new thing is that a like this. Now when you are going to imagine the one, you are going to not the original a, new thing.
Yeah.
And that's the problem. Okay, so now you know what I need to do separately. What else? I don't think I have any more ideas on how to trick you.
In the code that you have in GitHub, you have this is not this is something that you may have mistaked. You have C2 add C1 in the multiply part.
Yes.
And maybe it should be multiplied.
I'm trying to find it. Are you sharing the code? Show it.
Because in the exercise 4, in the test add you have R and just multiply it to that add.
Okay, right. It's a mistake. Yeah. It's a mistake.
Right?
Yeah, sure. Because you want to call the function multiply.
Oh, but then it will print plus as well.
No, you are confusing. The plus is not, it's not because of the addition. It's because of the fact that, okay?
Yeah.
That's how you represent the numbers.
Mistake. But you just you change the cell, use change cell and
You wanted to do in 44, you wanted to do C1 dot multiply? It's swapped, right? Well, the multiplication of A times B is indeed commutative. So you can do this, then this. But in our example, because we are multiplying and putting the result in the first variable, then it's not commutative anymore. If you do B times A, you will affect B and not A. So now, yes, it's different. It's not completely commutative, but it may be that you just want to do B times A. So it's okay. Okay, that's it. I have no more for you this class. Don't take long to start at least trying to do the assignment, the practical assignment, okay? Take a look at it because you have to deliver it next week. So it's not so much. It's easy, but it's not so much. And typically my practical assignments, it's just compiling upon everything you've learned. So you have almost examples for everything I ask, okay? Just have to put them together and do a bigger program, okay? So if you want, you can stay here doing the assignment. If you want to go, you can also go. I will stay here until, if you have any questions, I'm here, okay? Whatever you need. But in terms of new exercises, I have no more. Deu uma leitura.
Vou partilhar, não? Vou partilhar. Sim, obrigado. São duas formas de representar. Eu não uso isso, os meus alunos de doutoramento não isso, eu fico sempre com o cérebro todo trocado. Não sei porque eu não gosto disso. Olha aqui. So, new program. Let's call it copy-paste. Test strings. Okay, so if you do like this, variable 1 equals, or variable equals something between quotes, this is a string. If you print the variable, it will print the text, of course, here, and dot barra, where am I? Ponto barra test strings, clear, and okay, this is a string, makes sense. Now, you can check for every Python variable, which is the type of this variable, by printing the type of the variable. So if you print the type, it says, oh, this is a class string, okay? Now, your alternative is with the F string, which I never know how to use. It's like this, no? So this is a string, and now we can put here a number, like, let's say here we have the age equals 33, and we can put here the age. This is to put variables inside the text, right? So if I also print this, so by the way, if I'm going to do something completely similar from one to the other, I will have to put here age. Now, if you see, it's the same. So the print is exactly the same, and the type of variable v, which is returned, is also string in both cases. So these are just two different ways of creating a string. I use always the one on top, and my students always use the one on the bottom. I think it's just to annoy me, and it works. Yeah. Não é partilhar o ecrã? Não partilhar, mais fácil. Você já, oh André, você entrou só agora, você já fez as aulas de trás ou ainda está a tentar recuperar? Okay. E já viu os vídeos? Sabe que tem os vídeos das aulas, não sabe? Sim. Ah, sim, já estamos a ver. Complex takes no arguments. Isso é na linha 25, não é? Ok, ali na linha 25 ele diz, olha, o complexo não leva argumentos. Você pôs ali, quando definiu na linha 3 a função, você pôs int, underscore, underscore int, é underscore, underscore init. Agora experimenta agora. E é, não sei o que é que você está ali a fazer. Isso. Não, não está bem ainda. Vá lá, não está bem ainda. Você escreve def, espaço, o nome da função, abrir parênteses, os argumentos. Você tem def, espaço, o nome da função, 2 pontos, abrir parênteses. Ok, veja lá agora. Já está? Okay. Então, pode ir quando quiser, sim, quando quiser, quem quiser sair, pode sair. Em casa, sim, fazem em casa e depois, no início da próxima aula prática, vamos começar por vocês a mostrarem os trabalhos. Pode ser que se não falarmos inglês para nós chegarmos a conseguir compreender. Se quiser fazer inglês, pode. Se quiser fazer português, também não há problema. Diga, André. Pode perguntar o que quiser, pá. O que é que vão ter vestido? Passando. Não. More.
Beautiful. Up in your. Okay, I'm confusing. Oh, it's like.
It's very hard.
E aí, finalmente, você tem que ir para o Está-se bem. Está-se bem.